Suppose that you have one whole cake and you have a friend over and you would like to split it evenly across the middle between you two. So what do you get? You get one, two equal parts of the whole cake. We would like to have a mathematical presentation to one part of a whole cake. Obviously, this is not a whole cake on itself because it's one part. It's split into two. But what we know is that it's one part out of two total parts of a whole cake. So it's if you attach it to its original other counterpart, you get your cake back. Now this number at the top is telling us the number of parts that we have, and mathematically it's referred to as the numerator, while the one at the bottom is the total number of parts. So it's telling us how many parts did we originally split the cake into. And it's called mathematically as the denominator. This whole expression here is called a fraction. Now one can say that this is not the only way we can cut a cake. We can cut it in another way. And suppose we have the original cake, and instead of cutting it into two halves, we cut it into four equal parts. So we get one part, two, we get four equal parts, and let's say this part here on its own represented, well, it's one part on its own out of four equal parts of the cake. But now suppose that instead of having one part, I also took this cake as well. So now, instead of having one part of the cake, I have two out of four equal parts. But if we compare this to our original cake, we can eyeball it and say that 2/4 of a cake should add up to half a cake visually. So we can say that 2/4 is equal to 1/2 from that comparison. So these fractions must represent the same amount of cake. Now there's another way to go about this, and instead of visualizing it, we can cross multiply the two numbers and see what we get. So if we multiply 2 by 2 on this side, on the left hand side, and 1 times 4 on the right hand side, we get on the left hand side 2 times 2 is 4, while on the right we get 1 times 4 is 4, which are indeed equal, meaning that these two fractions are equal. Okay, now suppose we have the following fraction, 8/12. We would like to see if we can write it in simpler form, analogous to the way that we saw that 2/4 is equal to 1/2. Now we can notice that 8 and 12 share a common divisor. So 8 can be divided by 4, and also 12 can be divided by 4. And if we do the math, if we divide by 4 on both ends, we get that 8 divided by 4 is just 2, and 12 divided by 4 is 3. Now 2 and 3 share no common divisors, so we can say that this fraction is in its simplest possible form. And what I mean by simplest possible form, it represents the same amount. Suppose that you have a cake and you split it into 3 equal parts, then you take 2 parts out of 3. That is equivalent to saying if you split the cake into 12 different parts, and you took 8 parts to yourself, that would be the same as if you split the cake into 3 parts and took 2 out of 3. So these are equal. And we can verify again that they are equal by the following method. We say, well, if these are two are equal, we can just cross multiply both sides, and we get 8 times 3 on the left hand side and 12 times 2 on the right hand side. So 8 times 3 will give us 24, and 12 times 2 is also 24, so they are indeed equal fractions. Now suppose we have the following two fractions, 3 over 4 and 2 over 3, and we would like to know which one is bigger than the other. Is 3 parts of 4 greater or less than or maybe even equal to 2 parts of 3? The easy way to check is just to cross multiply again, and we get on the left 3 times 3, and on the right 2 times 4. On the left we get 9, and on the right we get 8. And 9 is greater than 8, so you can say with confidence that 3 out of 4 is definitely greater than 2 out of 3. So this is how we compare two fractions if they're greater or less than or equal to each other. We just cross multiply and see the values that we obtain and check. Now for a general fraction a over b, it is, if you multiply a by k, the top and bottom by the same number, then you are left out with the same fraction. What the following statement is saying is that suppose you have the following fraction, 1/2, then it's equal to 1 times 2 divided by 2 times 2, which is saying, well, the top is just going to be 2 and the bottom is going to be 4. It's just multiplying by a factor in the top and the bottom is just telling you, well, if you cut up the cake into halves, it's equivalent, and you have 1/2 of a cake, it's equivalent as if you cut the cake into 4 equal parts and you took 2 equal parts out of the equation. So here in this case we have a half, while in this case we have 2/4, which is the same, in principle, the same amount of cake, but you just increase the number of cuts. But for our purposes, mathematically, these are equal. They have the same mathematical value. Now we note the following. If we have a fraction a over b, so suppose you have the cake again, and if we cut the cake in half, and we can have one part, we can have 0 out of 2 parts, so we can get no cake. We can have 1 part out of 2, or we can have 2 parts out of 2, so we can get, which gives you back the whole cake. This gives you only a half of the cake, so just this area, and this you get nothing, right? But so a can take the value 0, so a can equal 0, right? But b can b equal 0? Question mark. Can it equal 0? Well, let's see what does that mean. Well, it's saying, well, if a is different than 0, then we're saying 1 out of 0. So it's saying you took one part out of nothing. But this statement in and of itself is nonsensical. So it's not giving any much sense. You can't take something out of nothing. Hence, you shouldn't be able to define by b should never be equal to 0. Okay, so your denominator b must always be different than 0. So as we said earlier, if we have a fraction 1 over 2, we can multiply by any number we want in the top and the bottom, and the fraction will still be the same. So this is equal to 3 over 6. Also, if we had, let's say, 2 over 4, and we divide by 2 top and bottom, this is also the same. This is also equal to 1 over 2. So it's the same as 2 over 4. It's still the same expression. However, you do not get to do the following. You cannot say, well, 1 over 2, well, I can add 1 to the top and 1 to the bottom, and it's equal to 2/3. This is just nonsensical, and we can prove it visually. So what this is saying is a half of the circle is equal to 2/3 of the circle. So if you cut up a cake into thirds, and you get 2/3, and you cut it up into halves and you get a half, these are clearly different amounts of cake. You can't do that, so hence you aren't able to do the same thing we did with the multiplication and division. And same goes for subtraction. So you cannot say, if you had 2, so if you had 2 over 4, you cannot say I can subtract 1 from the top and 1 from the bottom and get 1 over 3. This is also nonsensical. This is saying, okay, 1/2 of 2/4 of a cake. This is saying that 2/4 of a cake is equal to 1/3 of the cake. But again, these areas are not the same. So you can't do this mathematically. So, and this is a point which confuses a lot of students that are learning about fractions. So don't do that. You can only multiply and divide by the same number in the top and the bottom. You cannot add numbers and have the fraction be the same.